Yeah, let's go there. And what we're gonna do, we have 3D trigonometry. So just you remember what it means, right? It means that you have, yeah, just normal trigonometry but in 3D. Yeah. Okay. Yeah, so try the first one with the cuboid. They goes in the way of raising complexity in this case. That's for the angle, yeah. Let me fix that. Okay. And the way you did it, right, as I understand, you considered triangle BLD. Am I right? Okay. And so actually, yeah. I think you would use, instead of hypotenuse, instead of finding LD, because that's redundant, redundant operation, because you can straight use, yeah, tangent, right? Okay. Yeah, sure. Okay. Yeah, let's go to the next one. In this case, you have a square base pyramid, and you need to find angle theta. Okay, so okay, maybe let's discuss the logic here. All right. You're almost there, yeah. In degrees, yeah? Yeah. Okay, so just briefly discuss the way you did it. And oh, wait. I think, look, wait. Just to clarify, am I right that first you found AC and halved that? AD? No. I mean, you halved AD for what? In order to find which side? But the height, you mean km, right? Km. Yeah. But unfortunately, you cannot find height because in this case, you need to have, for example, CD in order to find half BD. Yeah, so sure, right. Either, let's say in our case, right, we need to find MC actually. Yes? MC. That's marked. Yeah, okay, I know. So C is the last vertex. It's hidden on the, yes, it's hidden under the panel. Okay, so that's C. And anyway, we need to find MC, right? Because we need to find this angle theta, right? So that's why we need to find MC first. And actually MC is the half of AC, right? Okay, so that's why for this reason, first you can find AC as the whole length, right? Pythagoras, because it's square based, so, but yeah, absolutely right. So you take in the square root, yeah. Okay, and you have that, yes? Later on you need to have that. Okay, so around 3.4. This is MC. Yeah, so in this case you can use cos rule. I mean, not cos, but trigonometric ratio cos. Okay. Yeah. And that's how we can express cos. Okay. Yeah. I understand your way. You decide to find the half, let's say, of AB probably. Okay. So perfect. And from there but make sure that your calculator switch on to degrees mode, because like many students use improperly calculators, like using phones, for example, smartphones, to calculate inverse function for cos, and they didn't switch to degrees mode because there are two ways: using radians and alternatively using degrees, and sometimes they get like very tiny angle in radians. Okay. Yeah, degrees mode. Actually, you need to work with degrees. Yeah. Okay. So take an inverse, you can find angle theta. Okay, it's done. Yeah, with this one. I mean, the final value that you'll get is going to be like very small number, maybe somewhere around, I don't know, in degrees. So actually, if you convert, let's say you found like around 60 degrees, yeah, for example. And 60 degrees you can convert into radians. Like 180, it's pi, right? In radians. 180 degrees. Do you know this correspondence? So radians can be matched with degrees. Okay, so that's why pi radians correspond to 180 degrees. And if you divide by this pi by 3 in order to get actually 60, you'll get pi over 3. And pi over 3, let's assume that pi is 3.14, right? Okay, if you divide by 3, it's going to be just 1/14. And that's the angle in radians. It's really like tiny value. Okay, so let's move next. Angle L. So in this case, okay, you need to find an angle between line DL and the plane, right? The plane is behind the line, right? So your line is actually BL. No, not that one. So, do you remember vectors? Okay. So what if vector in space, in 3D space? No, I mean, yes, in 3D, there looks like in 2D, but you just add another dimension, right? The third one. Okay, let's assume that you have the line LD here. And it just simply casts the shadow, right? Assume that you just lead the light. Yes, it will cast the shadow on the plane. So first of all, this is going to be the angle between your line, LD, and the shadow. That's going to be the angle between the line and the plane. Okay? Between the line and the shadow, right? That's how it works. No. The shadow, okay, can you detect the shadow in this case? If you light LC, right? LC, so that's why your triangle is going to be DLC, right? Yeah. And this is the angle? Yeah. DLC, right? That's your target angle. Okay. Because trigonometry is a bit more, like in 3D, it's a bit more complicated because it takes like different, harder questions about like between planes, between angle and plane. Yeah, okay. That's why I decided to give you that. Okay, so basically you understand that first you need to find the shadow length, right? And on 4 point, yeah, absolutely right. Yeah, tangent works perfectly here. All right, so let's move to the next one. Okay, so in this question you have again square base pyramid, and you need to find an angle between two planes actually. So how to work out the angle? KC and CD. Unfortunately not, because in this case you need to So actually, to find the angle, you need to put two perpendicular line to the line. Yeah, that's what I'm trying to explain you. Can you see the line of BC? So line BC in this case. This is the line of intersection of two planes. The first plane is ABCD, let's say quadrilateral there, yes? And you have also BKC, all right? Okay. And you see, but we but we still didn't like plot the appropriate lines, because in this case you need to put two perpendiculars to that line of the intersection. Okay, so in other words, you just need to use BC as the line, and from both points on two planes, let's say from point K, you put perpendicular down. Okay, it should be perpendicular. There is no other way to solve. If it's not perpendicular, you cannot use that. I mean, it's going to be the wrong angle in this case. So that's why you put perpendicular from K point, and also, for example, from M point. Yeah, maybe, you know, there is the problem that you might not be... Okay. No, not this angle, not this angle. So how to test? For example, your assumption is to find the angle KCM. Okay, let's test it. Is it exactly that angle? So KC is the line, right? And ABCD is like sort of the plane. So right now what you do by saying KCM is you're trying to find the angle between the line segment KC and the plane ABCD. But this is not the angle between two planes. Yes, it's on the plane. However, this is this doesn't mean that you find the angle between planes. That's the problem. Your line should be perpendicular to BC, okay? Yeah, perpendicular to BC. So that's why you need to put an extra line from point K straight to BC, okay? Yeah, okay, I'll try to show you maybe. Yes, I think it will work better. Just let me see. Okay, so just look here. Can you see that screen? Okay, so assume we use the point K and we just put the line which is perpendicular to BC. Okay, that's one line, yes. And here is another line that goes perpendicular to BC from point M. Okay, yeah, so that's the angle. So if I just simply make a cross section so that to use the flat triangle M, K, and say this point, let it be N, okay? Yes, this is the angle, okay? Yeah. Because angle KC, yeah, okay. This is sort of like rare, yeah, it's rare question. Yeah, okay. So in other words, if you have two planes, like one plane, I would say another plane, make sure you first put the cross-section line, yes? Okay, and then you need to put just line perpendicular to that plane, to that line of intersection and this line, okay? So it works like that. Okay. Yeah, I'm pretty sure. So, but anyway, yes. There are several ways actually how you can find, right? But the ideal way is to find Kn first, as you did, right? just use Pythagoras, 7.5 and half of 4.1, right? Okay, and then find mn. This is basically again half of 4.1. So now you use cos probably. Yeah. Okay. Yeah, it's done. Okay, perfect. So right now we switch to thirds. Okay. Yeah. So what about thirds? I also picked up some tricky questions there. Where is that? Oh, see. I guess here. Yeah. So that's sort of exam style questions, like similar to real questions. Okay. And they, at least I found that they're pretty hard for a GCSE student. Okay. I mean this. No. I'm talking about the third topic. You know, exponents and thirds. Yeah, you know that. Yeah. And let's consider the first problem, which is quite an interesting one. Okay, let's go there. Okay, here's in the chat. Yeah. You know this sort of questions, yeah? Yeah, many students told me that they're not aware how to work with that. And especially, it's not just, there is the hint. You just need to rationalize denominator, okay? This is the way. So you just, yeah. So you need to expand the brackets. But I don't recommend to do that in problem 1. I don't recommend. So, because your final target is to cancel the fraction, right? No, that's not the best way. I don't recommend to expand. I think because, look, in the question you need to actually get rid of irrational number in denominator. So that's why the best way is just to, to go to basically a rationalized denominator. I guess that's the best way. Okay. Not whole, but at least you need to get rid of those square root of 3 in the bottom. Okay. Yeah. Square root of 3 minus 1. Yeah. Do you remember the way how you can rationalize denominator? No? So you see that in this case is square root 3 minus 1. So you can actually times their conjugated expression. So conjugated in terms of square root of 3 plus 1. So the same structure, but instead of minus, you are going to use opposite sign. I mean, you multiply in both parts, denominator and numerator, by square root of 3 plus 1. Okay? Yeah, you remember that. Yeah. So no, it's impossible to find, yes, because It's a rational number. Okay. Okay, so let's multiply and just try to see how it works. Yeah. So both sides multiply by square root of 3 plus 1. You don't need to expand those like square, I think. Live for a while. I think just work inside the brackets. That's the best way, because you can work with square root of 27, why not? But before, so let's do just by iteration. So first, the first step, you multiply by conjugated, it means by square root of 3 plus 1, both parts, the bottom part and the top one. Okay, so assume that you did it. Okay, you multiply, and what you will have in the bottom in this case? Yeah, in the bottom part. Yeah, sure. Okay. Let's try to do that. I just started doing, but I roll back. Okay. Here you go. So that's the problem, and you multiply both parts by square root of 3 plus 1, right? Both parts. Okay. And what are you gonna do? The bottom part becomes a formula. A minus B, A plus B, right? Because in this case, A is square root of 3 and 1 is B, just simply. Okay, you'll get A squared minus B squared in this case. So next part. It means that denominator you can make as what? As simply square root of 3 squared, which is 3, yes? And B is 1. So this is square root of 3 and this is 1 squared, and you subtract. So that's why it's 3 minus 1, which is 2. Okay. So the top part, 1 plus square root of 3, and you times. Let's work inside the fraction, inside the brackets. Square root of 3 and square root of 27. Can you at least partially work out in simplest form of the third? I mean, simplify somehow. Square root of 27, yeah. In the bottom, one more time. So what we did, actually we used the formula. In your formula, a squared minus b squared becomes, yeah, a squared minus b squared becomes square root of 3 squared and minus 1 squared. Yeah, it's 2, okay. Yeah, but the top one. The top one. So we need to work with the top one. So in this case, square root of 3 and square root of 27. No, simplify. Square root of 27, look. 27 is 3 times 9. Yeah. Yeah. And then you simplify it. Yeah, okay. That's how you can simplify that. And it's still squared. Okay. So next, let's do the next step. Now you work with top only because no, it's too early. Look, square root of 3 and you add 3 square root of 3. How many square root of 3 you'll get? The easiest way, yeah, you understand, that's 4 square root of 3. So 4 square root of 3 and still squared and times 1 plus square root of 3. Now you understand why it's not recommended to expand. Because if you expand, you'll get like more. I mean, it's not convenient, you know. Yeah. Yeah. I mean, now you can raise to the power of 2, definitely. Yeah. So yeah, it's going to be 4 squared and times 3, so that means it's going to be 16 times 3, yeah? You just need to simplify on the run, on the go. Okay. Too early. I mean, first you cancel it, it's easier. Yeah. And then you multiply. Okay. Yeah. So you understand that's, yeah. So 24. Yeah. And now you actually got it, right? You have this expression with a as the factor. So a is, yeah, a is 24. Okay. Yeah, you agree that it's worth to solve like at least one of this question to be sure. However, they can be, you know, they can be arranged in different ways. So, for example, what I found actually sort of something connected with a sequence, and it's definitely hard. Okay, yeah. So I'll try to show you. I mean, I'll send you right now. Know what I mean? Okay, so if you want, you can do self-practice right now, quick, while I'm picking up another problem. Yeah, this one. That's okay. Problem 2 thirds. Yeah. Yes, you can actually. Why not? You can. Yeah, you can. You can factorize 5. Yes, from the top, it's already 5, and from the bottom. Yeah. Yeah, definitely. not sure because, I mean, yes, there is no reason in calculations. Yeah, you see that every step we can do mentally, or at least it might be, for example, calculator, but you are not supposed to calculate the surds, right? You need to leave the surds because. So typically, what do you think if you have surds question? Is it typically for non-calculator? Yeah, definitely, right? However, it's gonna be like the last hardest question, right? Okay. Somewhere in the end, yeah. Yeah. No. So your first step was actually correct. So you factorize 5, right? From both sides. I mean, from the top, yeah. You factorize that, yeah, you cancel. Yeah. I mean, if you factorize, you'll get 1 over 1 plus 1 over square root 3. Yeah. No, sorry, not 1 over square root 3, but 5 over square root 3 here. Yeah, because you factorized 5. Yeah. Definitely. Okay. Yeah. 1 plus 5 over square root 3. Yeah. You just simply take away 5 from the top and the bottom. Okay. Wait, don't think about 22. I know that you trying to... It's too early. No. There is no way, it's multi-step problem. And that means it's too early to think about 22. But you understand that in the bottom part, you need to get some whole number. No matter which, right? But the whole number. It means you just, again, you need to get rid of surd, right? Yeah, the root. What if you just come to the common denominator? So you have 1 plus 5 square root of 3, yeah? 5 over square root of 3. What if you just line up 5 over square root of 3, yeah? Yeah, I'll just show you what I have. This one. We take away 5, yeah. Yeah. Okay, and now, what if you just come line up denominators from the fraction? Instead of 1, you can make a fraction, right? With denominator square root of 3. Why not? The bottom part, No way, no way. So 1 over, and instead of 1, you just make in square root 3 over square root 3. Right? This is the way. Yeah. Because it's 1. It gives you 1. So make sure you can come back to your original number 1. Because otherwise you won't have 1, right? As the result. Okay. Yes, and now you're actually doing 1 over, and you just 5 plus square root of 3, yeah. And over square root of 3. Okay. So you should have this sort of fraction right now. Yeah. Okay, and now what are you going to do? Because you divided 1 by 5 plus square root of 3 and square root of 3, you can consider as square root of 3 over 5 plus square root of 3. Just imagine you dividing by the fraction 5 plus square root of 3 over square root of 3. And instead you can multiply, right? Like this. Okay? Okay. Okay, so now you have the fraction as in the previous case. What you can do? Again, rationalize denominator. So you multiply by 5 minus square root of 3. And the top part as well. Okay. Yeah. Just swap the sign, right? Here is the plus sign, now it's minus. Mm-hmm. 25 minus 3, yeah. Mm-hmm. Yeah, so it's going to be something like this. So finally you'll get 5 square root of 3 minus 9, yeah, over 22. Nine, yeah. Oh, yeah. So you mean when you multiply square root of 3 by square root of 3, square root of 9, yeah. Sure. Yeah. Yep. Okay. Yeah, it's complicated, but however, it's good to like see at least once, right? How it works. Definitely. Okay, and from there you can find what stays for A and B. So A is 5 and B is negative 3. Okay, in this case. Okay, so perfect. Yeah, it's done for now. Okay, so yeah. So tomorrow we'll have a day off, right? Okay. Yeah, sure. You actually you trapped in quarantine, right? Yeah. It's because of the school. What? Oh, okay. Yeah. It's interesting one. Okay. Okay. Yeah, I see that. Alright, so anyway, yeah, thanks again. Yeah, so we'll type messages. Alright. Yeah, for sure. Okay, see you later.